Welcome to the module on General Overview of Perforation. Today, we will learn about history of perforation, well completions, types, well conditions, and conveyance, shaped charged components, intelligent perforating process, arrival at site, perforating safety, detonators, radio frequency concerns, return to surface procedure, and after the job. Introduction. Perforation is the communication tunnel created from the casing or liner into the reservoir formation, through which oil or gas is produced. The most common method uses jet perforating guns equipped with shaped explosive charges. However, other perforating methods include bullet perforating, abrasive jetting, or high-pressure fluid jetting. Perforating connects the wellbore with the pay zone of the reservoir. It provides the flow path for reservoir fluids to enter the wellbore. Successful stimulation and sand control operations are strongly dependent on perforation parameters. It is a key factor in well productivity. It is a dangerous operation that requires careful planning and execution. History of perforating. Mechanical, nitro shot prior to 1932. Use of bullet gun, 1932 to present shaped charge also used, 1946 to present spin-off from DoD and DOE technology. Most popular techniques are hydraulic, 1958 to present, and abrasive jetting. Well completions and conditions. Types: cased hole, open hole, and gravel pack. Well conditions: overbalance, underbalance, and extreme overbalance. Conveyance: wireline, tubing, and coil tube. Cased hole completion. Usually, unconsolidated rock needs a casing and cement to keep well stability. Well is then perforated, or casing cement formation, in order to produce hydrocarbons. Gravel pack completion or gravel packed liner. It is used as a screen to keep unconsolidated formation out of the wellbore. Fluids can flow through the gravel and screen. They are most commonly used in unconsolidated sandstones. There are three conveyance methods for perforating guns: through casing, through tubing, option for magnetically excentered, tubing, or drill pipe, conveyed. Let us see a visual illustration for the same. Tubing conveyed perforations. In this case, the perforation carrier is an integral part of the production tubing. The technique commands that the guns are a part of the completion tubing, usually at the bottom. Gun firing can be made hydraulically, mechanically, or using electric cable. When the well conditions are overbalanced, the wellbore pressure is more than the formation pressure. Formation is not cleaned after perforation. When the well conditions are underbalanced, the wellbore pressure is less than formation pressure. For optimum perforation, perforations are cleaned right after gun firing. This maximizes the productivity. And, if the well conditions are extreme overbalanced, it creates fractures in formation right after perforation. Next, if the well condition is overbalanced, perforations can be done on all conveyances. Wireline is preferable as it is faster and cost-effective, whereas coil tubing, CT, is applied on deviated or horizontal wells. Also, if the well conditions is underbalanced, perforations can be done on all conveyances. Tubing conveyed perforation, TCP, is preferred. We can also use through tubing guns on wireline and wellhead equipment as required. TCP and CT is on deviated or horizontal wells. Shaped charged components. The three main explosives used in a shaped charge are RDX, cyclotrimethylene trinitramine, HMX, cyclotetramethylene trinitramine, and HNS, hexanitrosilbena. The main difference between these explosives is their temperature stability. RDX is commonly used in environments less than 330 degrees Fahrenheit. HMX is used for temperatures up to 400 degrees Fahrenheit, and HNS is suited for temperatures up to 520 degrees Fahrenheit. Each shaped charge generally contains between 3 and 60 grams of explosives. Shaped charge mechanism. Shaped charges are capable of releasing energy instantaneously in an explosion. They use a cavity effect and metal liner to maximize penetration. They consist of four components: primer, main explosive, conical liner, and case. Explosion travels down the cord. Primer is initiated. Main explosive detonates. Detonation advances spherically, pressure up to 7.5 million psi. The charge case expands and liner collapses to form high-velocity jet of fluidized metal. This is propelled along the charge axis. Let us see a visual illustration of shaped charged components. Intelligent perforating process. It includes the following steps. Step 1. Reservoir description viz seismic logs etc. Step 2. Completion design viz simulators, nodal etc. Step 3. Job design. Step 4. Execution, optimization, including hardware, treatment, gun deployment. Arrival at the well site. This includes the following steps: consult with client, establish presence, verify job, confirm procedures, check for hazards, inspect site, check for transmission towers etc., hold spot safety meeting, include client and all other safety personnel, and designation of no smoking area. Perforating safety, detonators. Hazards from potential differences, PDs, involved while perforating, radio frequency, RF, radiation, impressed current cathodic protection, electric welding, high-tension power lines, inductive coupling from large induction motors, or rig top drive motors. Detonators for perforating guns. Detonators are required to initiate detonation train through guns. Below are the types: conventional detonator, percussion detonator, and secure detonator. Radio frequency concerns. Put out signs. Deactivate all radio transmitters within 1,000 feet, 300 meters. Do not proceed if you are within 5 miles, 8 kilometers of a large transmitter, radio or TV, or within 200 of high-voltage lines, or if well site transmitters cannot be deactivated. Arming or disarming a gun must not be attempted during thunderstorm, dust storm, sandstorm, helicopters or boats approaching. Return to surface procedure. Do not retrieve the gun above 200 feet, 70 meters, downhole during storms or their imminent arrival. If the guns did not fire, disarm the lowermost guns first before disconnecting the head. Relieve any trapped pressure immediately upon removal from well. After the job, police the site for any remnants and pack them in an explosive remnants box for return to the district. After perforation, flowing the well can help in cleaning the debris from the perforations due to the resulting drawdown between the wellbore pressure and the formation pressure, but as the drawdown decreases with time, the cleanup process through the perforation also gradually decreases. Thank you for learning with us.